Hey, what's up? Jason here. Today we're going to talk about the static keyword and the singleton pattern. I'll explain what they mean, what they are, how the two of them relate, when to use each of them, when not to use them, and what kind of issues to watch out for when you decide to actually implement one of these things into your project. So we'll start with something really basic, and then we'll build into some of the more advanced singleton patterns that you may have seen out there, and we'll kind of dive into how they work and why they're set up the way that they are. Now, before we dive into the more advanced stuff, I want to cover the basics of the static keyword. So here I've set up two classes. I have a myStatic class and a myNonStatic class. And the only difference here is this static keyword. And I've also set up this class here on line 11 that's going to try to instantiate both of these to show one of the main differences. Here you'll see that on line 15, we create a new instance of the myNonStatic class and assign it to this instance variable. If I try to uncomment line 16 here, though, you'll see that we get an error, and that's because we can't create a new instance of a static class. There's only ever one instance of it. It's this thing right here, and we can't actually new it up or do anything to create one. We just can have that one, and that's it. So we can access things on this, though. So if we had a property on it, maybe like a public static int for score, we could then call into myClass.score here and maybe even increment it. So see on line 16, we'd now be incrementing this variable every time this thing instantiated. Not super useful, but hopefully you get the idea. Another important thing to note, though, is that we can't add a non-static property or method to a static class. So you see we've got an error here saying, hey, static class can't have a non-static property. So if you have a static class, you can only have static properties and static methods. However, if you have a non-static class, you can have a static method on it. In fact, we'll dive into a real use case for where that comes in handy for keeping track of mono behaviors. We use tanks in this example. And hopefully that'll make a lot more sense once we do. So let's dive into another example. Let's actually look at, well, first let's get rid of that line of code so we get rid of the error. And let's look at a unit manager that's a completely static class. So here I've got my unit manager, and this would be the way that I would set something up that doesn't necessarily need a game object in the scene, but needs to keep track of a group of data and maybe give me back specific units or give me back a set of data that I can query. So here you'll see we've got a public static class. Static keyword is very important there. And then on line 7, I've got a static list of units. So this is, again, works just like a normal list would in C#. It's just that we can only have this one instance of it. And we can new that list up. So just because we can't new up the static class doesn't mean we can't new up the properties. We can do that. So we've newed our unit list. And then we have an add unit method. Notice that this is also static. It's public and static. So we can call in and it'll just add to this unit list. And then we have a getUnitsAtPoint, another static method that returns here an IEnumerable. It's really going to be like a list of the units. We can pass in a point and a distance, and then we just filter through this list to find the ones that are within range of that point. So this is like a nice, easy way to keep track of a list of things and then get ones that are at a specific point. Of course, if you get to a certain scale, this could become unmanageable, and you will want to do something like a quad tree or an octree or something better. You also might want to replace the link with something else. This is, again, just to show the static and singleton stuff. So don't worry about optimization here if that's something that you're concerned about, right? So here we go. This is a unit manager. And again, this is a pattern I've used a lot, but it doesn't work great for everything. There are some cases where I want to do it a little bit different. And that's like this tank example. Here we have a tank mono behavior. So imagine this is on a player tank where we have some RTS going on. We've got tanks moving around. And I just want to keep track of all of the enabled tanks. Now, tanks may not be the best example for this. It could be particles or apples or whatever it is. But if I want to keep a list of all of the enabled tanks and I want to have a nice, easy place to access them, I can easily just drop in a public static list, name it all enabled tanks, you see. And then in onEnable, I can still access this static list. So I can just add myself to the list. So whenever a tank is enabled, it adds itself to the list. Whenever it's disabled, it removes itself. But this list is accessible anywhere. In fact, let's go back to the myStatic class and watch. If I wanted to do something with it, maybe I'm in an update here, I can just do tank dot all enabled tanks and just loop through this list, I go like for each var tank in all enabled tanks and do something. And here I have a way to find all of these tanks and to keep track of them without having to do something like a find object of type or having to keep a reference to a list of things. Now I just have a static list of them. It's going to be the same. It's going to work, and it's easy to get to. That's all great, right? So this is a lot of simple static stuff that we can use and things that hopefully can kind of slot into your project and make things easier. But a lot of the time what we want is actually a singleton. And really when I say a singleton, we want a monosingleton. We want a singleton of a game object in our project. We only want one instance of it. We don't want more than one, and we want it to be able to move around or control something. So to do that, we use a slightly different pattern that still uses the keyword, and that's that singleton pattern. And I want to take a look at this audio manager example. So let's zoom this up. This is, again, the most basic one. You see, we've got a lot of examples coming. But we've got the audio manager class here, and the base class is a mono behavior, so we can instantiate it. In fact, let's go take a quick peek at that in Unity. If I open up my audio manager scene, you can see I've actually got the game object here. We've got the script on it, and we'll just jump back in. Just kind of want to show where it was and what it was doing, because we're going to run in just a second, and you'll see what it does a little bit more. But the important part here is line 6. We have this public static audio manager. Notice it matches the class type, and it's named instance. It has a getter that's public, and then the set is private, because most of the time with a singleton, we don't want something else setting the instance of it or the static reference to it. And we'll see more about that in just a moment, because that's what we're doing right here on line 7. Or no, I guess it's line 9, right? So in our awake method of the audio manager, remember awake for a Unity mono behavior is called when it starts up. And when it starts, we just assign the instance to the game object that was enabled. So this thing turned on, it spawned when we loaded into the level, and we've now assigned it to this static variable named instance. And we're also caching the audio source. So how would we use this? So we just call audio manager.instance.playClipAtPoint. And what it's going to do is find the game object with this reference right here and tell it to play something. So let's try that out. Let's see what this looks like in some actual code. In fact, what I'll do is I'll just create a new method here. Let's create a new class. We'll make a public class audio input player. And it'll be a mono behavior. Whoops, got to capitalize my B there. And then we will maybe do an on update. So do update. And we say if input.getButtonDown fire1. Then we'll call audio manager.instance.play. Well, look at that. We can't actually play a clip because this is private. So if we make this public, then we'd call play clip at point. Give it a clip. So just say like whatever audio clip. We'll have to create one. And then we would give it a point. So maybe give it like vector 3.0. And then this would be enough. So now our audio input player, just assign a clip here. Maybe we'd add the serialized field attribute so we could assign a clip in the editor. And then whenever we click fire 1, which is the left click button, we'd play a clip at the point on this audio manager. Probably move that out to its own file and even see it run. So if we go into Unity and then we look at our audio manager, by the way, if we hit play, watch this. You're going to see a bunch of children appear underneath this audio manager. And this is the kind of thing that you'll see with singletons. They'll a lot of time do some sort of setup of their own. So here we've got audio sources. And then I can just spawn up, well, where did I put my script there, my player? So I could put my audio input player in here somewhere, maybe even just drop it on the camera. I could assign a clip, and then when I click, it would play. But I don't have a clip, and I don't want to make you go wait through that. So hopefully you get the idea, though, that here we have a reference to a thing that we can use whenever we want from anywhere in the code without needing to go in and link up the audio manager. Our other script doesn't need to know where the audio manager is. It doesn't need to know what the audio sources are. It just needs to say, hey, audio manager, go play this thing. And then the audio manager script, which is its own singleton, could figure this all out. And again, here's the script for creating that set of audio sources. Nothing special, totally unrelated, but if anybody is curious what it looks like, that's what it's doing. Just spawns them all up, puts them into a queue, and then we play some stuff off the queue. So let's dive into a slightly more complicated instance management of singletons, or the, where is it at? The auto cleanup singleton, perhaps? Let's check that one out. So here, notice that things are quite a bit different. In fact, maybe I should go with a simpler singleton first. Let's do that. Let's go with this lazy instantiated one, which I've noted is my least favorite type. And I'll explain why in just a moment. First, let's explain how it works. So if you're not familiar with the syntax, don't worry. It's very common C# stuff, and you'll get familiar with it relatively quick. But what we have here is a class that's using generics. So we have this public class, lazy instantiated singleton. I just gave it a long name to differentiate it from the other things. A lot of the time you'll see this as singleton or monosingleton or something like that. Then we have the greater than and less than signs around the T. That is for the generic type. What this is saying is that we're going to require a type for our lazy singleton. Whatever that type is, well, it's defined over here. It will have to be a mono behavior. Now, this part I think is very confusing. Let's split this into two lines. What's actually happening here is the lazy instantiated singleton is a mono behavior. That's what this colon mono behavior means. Then the next line here, which it doesn't matter where it is specifically, says where T colon mono behavior. What this actually means is that T, this part right here, must be a mono behavior as well. So this wouldn't necessarily have to be a mono behavior. It could be like T equal where T is some class, like it could be some tank. It could only work with tanks, for instance, or only some interface. We'd get some errors though, because I've got my script set up to work with singletons or with mono behaviors. So what we do here is we set up an instance of T. So this is going to all kind of automatically happen when we compile. It's going to fill in these types. We're not going to see any change in our code, but it's going to fill it in kind of in the back end in the code that it generates. We have a static instance of that, and then we have this public static instance of the same type. Notice the difference just in the casing. And then in the getter, we check to see if the static one is null. So for the first time through, it's going to be null. If it is null, we call find object of type and pass in T. So you may have recognized this generic syntax a little bit more now, because we use it a lot for things like find object of type or get component. Same kind of thing here. We're just creating our own class that lets us do generics. So if we still don't find anything, so if we do the find and we don't find anything still, if there's no instance of whatever T is in there, again, it could be a tank, it could be an audio manager, whatever, we don't find one, then we create a new game object, and here I'm just naming it instance of, and then type of T is just going to give me the type, and then it's going to get toStringed to the name, so to say like instance of audio manager, instance of unit manager, or whatever the class name for T is. So we're getting that new game object, and then right here, I'll just drop it down a line. We're actually adding the component of type T, and then that's getting assigned here. So we create a new game object. In fact, if I split this out, like var game object, or let's call it geo, and we do like geo.add component. All right, so we're creating that object, we're adding the component and assigning it to the instance. And then we return the instance. So what this does is create whatever the thing is on demand. So if we don't know when we're going to need the object, we may not need the object, this pattern can come in pretty handy. So things that I would use this for, like store connections or rare things that we don't necessarily know that we're going to need. Now, most of the time, I just won't use this pattern just because I don't feel like I have enough control over the life cycle. I don't really get to control when the game object is created or when the component's set up. And if I want to do any initialization or anything, I might not be able to do that. So I prefer to not use this method, but it does work and it works just fine for most things. Let's go on to the auto cleanup one though. So one of the issues that you'll have here with the lazy instantiated singleton is dealing with cleanup between scenes. So if we go into this lazy instantiated singleton, you see that we create an instance of the object, but when the thing gets destroyed, we don't clear this instance out. So if the game object that we had created, maybe it was an audio manager, was there, we loaded it up in scene 1, we went to scene 2, the thing got destroyed, our instance is going to be null. We're going to end up creating a brand new one and recreating it, which actually I guess isn't terribly bad. So it's a situation where if you want to recreate these things every time you load, this can work just fine. But a lot of the time we want to not recreate things. And that's where this kind of pattern comes in, which is just a tiny, tiny little bit different. Here we don't create a new instance of it. Instead, what we do is on awake, we assign this thing to the instance. Oh, actually, I didn't even do that. I'm lazy instantiating them, but on awake, we just destroy it. So I kind of lied there about how I set this up. I really did just set this up to clean itself up, not to instantiate a different way. So it still does the lazy instantiation. Sorry about that. But it does do this cleanup here. And to do the cleanup, we just check to see if the instance is null or not null. And if it's not null, we destroy this. So what happens is we go in, we have an audio manager already there, and we load into another scene. It also has an audio manager. This new audio manager, since the instance is already set when awake calls, will just destroy itself and go away. Now that can still cause problems if your audio manager or whatever the thing that you're instantiating is doing something when it starts up, because that thing would still happen. So you got to be wary of that. Think about it. Think about the life cycle of these things. But let's dive into an actual example of using one of these singletons. And I got that right here in this UI manager. So here you'll see we have this auto cleanup singleton as our subclass or our base class, and we kind of define it a little bit weird. Let's zoom this way in. So when we're setting up one of these singletons, we say public class and we give it the class name. Then we give it the base class and then the type of our existing class, which I'm sure kind of blows people's minds a little bit and confuses people. It did for me the first time. I was like, what the hell is this? This doesn't make any sense. But what we're actually doing is we're saying this is actually one of these with the type of T being UI manager. So what we're really getting is our UI manager has the instance flag on it and the instance variable. And the awake method here is going to be called on it. So if I wanted to do something with our UI manager, let's go back to that static class where I'm just kind of messing around. And we could say like UI manager.instance.gameObject.setActiveFalse and return off our UI. Right? We want to get that game object and reference it somehow. This will do it. So this instance, again, is on that base class, but accessed through our UI manager. Now, here's one of the issues that you're going to run into with this. So if you use this pattern and you do something like, hey, Void, awake, do some cool UI stuff. You can be like, okay, cool. I added some UI stuff to the awake method. Everything's good, right? Now it's going to do the special stuff. Unfortunately, you're not even going to know it, but it's going to break this. So this code right here will not get called anymore because the awake in the UI manager class is called instead. So big issue here. And this is something that I've seen happen, I don't know, dozens of times and cause problems where people added an awake or added a start or on enable, whatever method it was that the base singleton was hitting or using to assign something. They start implementing that in the other class and then it causes problems, which is mainly, I'd say, the primary reason that I almost always just stick with the nice, simple, non-reusable, non-generic version of singletons now. I also try to minimize the use of singletons and not go overboard. And I said I was going to talk about when to not use them, and I think now is the time to hit that. So in the past, I've told people, hey, don't use singletons. They can be bad. They'll cause problems. It's not really true. Singletons can be perfectly fine. They'll work great, and they can solve a lot of problems. They're just very, very easy to misuse, overuse, and cause problems with. The biggest issue that people cause themselves to kind of dig into a hole and kill their project with is putting a bunch of state on these singletons and then accessing that state from anywhere in the project. So they'll have like a gameplay singleton or a game state singleton, And it's got all this stuff on it, all these properties, the lives left of things, the positions of stuff, the number of things that are going to spawn. And they'll have all these other classes that are calling into this one singleton and changing the data from different points. And that is, it's the biggest problem that you're going to run into is you find people just using them as a quick shortcut around some cleaner architecture and thinking through the problems, and they're just going to slap stuff into there, pull it back out, and it'll be great at first. It'll be super fast. Everything will work. It'll be fast. You'll be just chugging along. And then the project will hit a certain scale. It'll start to get harder. You'll start to see side effects of stuff. You'll change something and something else will happen. Or you'll run on a different platform and you'll notice that the reading and writing of the data in this singleton is no longer in the same order that your code was expecting, that you didn't even know was expecting it. You can run into a lot of these problems. And again, the biggest thing is just the state management becomes a giant mess. So don't go overboard with your singletons, and make sure that you don't put just a bunch of publicly accessible data that's modifiable. What I like to do instead is, if you're going to go with singletons or static stuff, put methods there that handle the functionality that you want to do, and have those methods change the state of things internally if you're going to store state. Now, I want to wrap this up by talking a little bit about unit testing, but before I do, I wanted to give a special thanks to everybody on Patreon. You guys are awesome. Really appreciate it. And if you're still watching this video, please just go out and share it somewhere. Drop it on Facebook, whatever place that you like to visit frequently and people might see that are interested in game development. Just share it. It really helps a lot, and I really appreciate it. So let's talk about unit testing real quick with singletons. And I think this is probably the biggest thing that I have against them. And it's just that testing code with singletons is very, very hard, partially because of that shared global state that singletons and static variables give you, but also because most of the time the singletons happen to be around mono behaviors. And if you write unit tests in your Unity code, you know that unit testing mono behaviors is kind of a pain. So I generally don't do much in the line of testing with singletons, but there are cases where I'll have some static data or a static class that might have some state that my unit tests need to run. And in that case, a lot of the time what I'll do is mock out a little bit of special code. So say I've got a static class that provides, one great example is I've got a class that provides data from a database. It loads the data at runtime, fills it all up, and just provides some data to the game. It's a game server in this case. But I want to be able to test it without connecting to that data. So in those cases, what I'll do is just give myself a way to inject the data. So instead of downloading the data from the database, I'll just new it up in my test and inject it into that singleton. So to do something like that, it's more like a, and it said singleton, but I really meant like a static class. In that case, what I would do is something more like public static list of whatever, I'm going to put string here, but imagine this is some data object of tank data, or tank data is new list of string. And then maybe this is getting filled from some database source or something. And what I'll do instead is write a test that just fills this data and populates it to get ready for it. And that's something that you need to be prepared for if you're going to write tests, is make sure that if you're using singletons, that you've set them up in a way that your tests are still going to work, that you're still going to be able to unit test your code and be able to inject in the correct data and only the correct data that you want, and not have to pull in all the data to run a test every time, because that's a terrible idea and it would be really, really slow. So again, if you're testing, you can test with singletons. You just need to think about it and be conscious about it. And I would say if you aren't writing unit tests and you're using singletons, try getting into unit testing, because it's going to make your singletons dramatically better. They're going to be a lot more versatile. You're going to end up finding that you're not wanting to fill in static state as much and not running into the issues. At least that's been my experience. Who knows? It could be different for everybody. Anyway, I hope this was at least a little bit helpful. If you have more questions about static and singleton stuff, or if you have good suggestions, recommendations for other singletons that people should use, please drop them in a comment down below. I might link the previous singleton posts that I've made that have some of the code that you can pull to if you want. But I'd be really interested to see what other people use and what other people like, because it's all about learning stuff and getting better, right? All right, thanks everybody. Goodbye. Don't forget to like, subscribe, and again, remember to share if you got this far. I assume you already did, right? Cool. All right, thanks again. Bye.